Okay, so graphing reciprocals. So let's say we're given something that looks like this. F to the exponent of -1 of x equals x plus 3. First of all, although this looks confusing, it just means make the reciprocal of x plus 3, which we all know is 1 over x plus 3. We simply just, normally this is over 1, so we simply just flip these two, and we're given 1 over x plus 3, and that's our reciprocal. But now we need to graph this. So let's start by just graphing the original to keep things easy. Our original is x plus 3, and this is a simple y equals mx plus b graph. So we know that it'll be a straight line, and the y-intercept will be 3, and we have a straight line with a standard slope of 1 over 1, so we'll get something that looks kind of like that. So now that we've graphed our original, we can start to think about graphing our reciprocal. Now, the first thing we need to do when we graph our reciprocal is find the asymptotes. The asymptotes are the values that the reciprocal function can never equal to, or are non-permissible values, or however you want to call them. Basically, the asymptote is when the denominator is equal to 0. For example, here, if I was to set x plus 3 is equal to 0, I subtract 3 from both sides, and I would find that for the denominator here to equal 0, x would have to equal to -3. So this is now our equation for our vertical asymptote. So we find the line x equals -3, and we can just lightly dot that in, and this is our vertical asymptote. This is a value that the reciprocal graph will approach and come close to, but will never actually reach. And the BC grade 11 curriculum for pre-calculus doesn't ask you to move your asymptote up or down, so we always know that our horizontal asymptotes will be found at 1 and -1. And then we can draw these in, and we'll notice that they'll intersect our lines at certain points. Then we can just draw in our reciprocal, and we know that the reciprocal is basically the opposite of the original graph. So as this graph goes up, the reciprocal will come down. As this graph goes down, the reciprocal goes up. It's just this opposite movement. And we notice that it passes through the horizontal intersection with the standard graph. And so we're left with something that looks like this. And notice that these values, although they approach 0, x, or let's say the denominator, can never equal to 0, because you can't divide by 0. So our x value cannot equal to 0, and our y value cannot equal to 0. And that's why that these graph lines will approach 0 but never actually reach it. And that's how you graph a linear reciprocal. So what if we have to graph the reciprocal of a parabola? Well, first we'll see this sign and we'll go, okay, that's reciprocal sign, so we might as well write out our equation to be 1 over x squared minus 3. And then we'll proceed pretty much just like we would as if we were going to be graphing a linear reciprocal. We'll draw our original graph from our original equation right here, and we know that the vertex point is not moved left or right, but it is moved down 1, 2, 3. So there's our vertex point. We notice that the slope is the standard parabola slope, over 1, up 1, over 1, up 3, over 1, up 3, and so on. And this gives us our basic parabola. But now we need to start looking at things like what are our asymptotes? So to calculate our asymptotes, if you remember from when we graphed a linear reciprocal, we tried to set our denominator equal to 0. X squared minus 3 equals 0. So we add 3 to both sides and we square root it. So x is equal to the square root of 3. But because we are square rooting an exponent or a power, it can be the positive or negative values of the square root of 3. And those are our vertical asymptotes. So we draw in our vertical asymptotes here and our vertical asymptote there. And one thing you might notice is that the vertical asymptotes here, now we have 2 of them, whereas our linear reciprocal we only had 1. So adding 2 of them means we'll have 2 reciprocal lines. And don't worry too much about this, it's really not that hard. Again, we can just sketch in our horizontal asymptotes at -1 and 1. We sketch those in, mark the intersection points, And just because this is starting to look complicated, I'm going to move over to another graph. And I'll just draw in vertical asymptotes, horizontal asymptotes, and where they intersect on the graphs. So now that we have all these points drawn out, I can just lightly draw the parabola over top. And so now, just like before with our linear line and when we made a reciprocal of it, as this gets larger and approaches the asymptote, or gets farther away from the asymptote, we get a line that looks like this and like that. And we get a mirrored image on the same side. And although it can approach the asymptotes, the denominator can never actually equal to 0. So we have these lines getting closer and closer, but they never actually equal 0. On the bottom, it's a little trickier. We know that we'll have a line that approaches the asymptote on the bottom and goes down indefinitely. However, we get sort of an inverted parabola, and we can find where the vertex of this inverted parabola is by finding the reciprocal of our original vertex point. And we know our original vertex point here to be -3. And what is the reciprocal of -3? It's -1/3. So we can draw that point in and draw a line and connect those 2 dots. And that's how you graph a parabola.